So thank you for having me, and good morning or afternoon or evening, depending on time zone, because I know a few people are calling in internationally. My name is Sean Mckeown. I'm a lecturer at Edinburgh Napier University, and this is some research that I basically just stumbled into because I'm a bit of a I've got a bit of interest in file formats, and I came across the high efficiency image file format, which has been used by Apple, or at least it's most recently been picked up by Apple. So basically, I want to talk about the forensics considerations for this file format, mostly because there's not really a lot out there, and I'll talk about that a little bit briefly in the next few slides. So I've got contact information along the bottom, and that will stay there throughout the whole talk. Right. So why am I talking about HEIF in particular? It's called HEIF or HEIC. So the file extension, as I'll mention in a second, is .heic or HEIF, depending on specific factors that I mentioned in the paper. But in the pronunciation is HEIF or HEIC, so it sounds a bit strange. So why this format? Well, basically JPEG is very, very old. At this point, it's it's 1992. So what's that? It's 28 years, which sounds a bit bonkers for a format we're still using. And mainly the reason we're still using it is because even though we've got, I'll just skip ahead a moment, even though we've got newer standards. So there's a JPEG, it says JPEG, but it's supposed to be JPEG 2000. So JPEG was reworked in 2000, but it was never really picked up. And since we've had all these other formats like BPG or WebP, which is by Google, more recently we've got JPEG XT or AVIF. So all of these formats are much better compression. They've got better features. So here we can see things like HDR is a fairly big thing of late, 10-bit color depth, transparency, animation. So right now, if you want transparency, you're pretty much going for something like a PNG. If you want animation, you're going for a GIF or GIF, depending on who you believe that should be pronounced. So we've got this mishmash of formats, and most of them aren't really as efficient as they could be. But the key thing is that the ball hasn't got rolling. There's not enough critical mass behind any of these formats yet for them to be picked up as a JPEG replacement. And another thing is that JPEG has got blocky artifacts. So we're doing our best with JPEG, but it's a bit long in the tooth. So HEIF has come along in 2015, and it's actually been updated in 2017 when Apple picked it up, and it's looking to solve some of these problems. So the first thing is it's allegedly up to a 50% bit reduction over JPEG, which basically just means you've got smaller file formats. So I tested this with a random PNG I got on the internet. The PNG 1870 by 958, so it's fairly big, not huge, not a huge image from a modern camera. The raw PNG was about 5 megabytes or 5 mebibytes. I usually go with the base 2 sizing. The JPEG was about half a megabyte, and the HEIF compression was a bit smaller than that. So you're not always going to get the full 50% reduction, but most of the time it's doing better than standard JPEG. But again, we've got things like HDR support and support for animation, and we've got fewer artifacts and allegedly better quality, although you see a lot of dispute over this. The scientific work says that the quality is better, specifically less blocky artifacts and colors and things like that, but the implementations I've seen so far haven't necessarily been better. The screenshot I was going to use here was actually from a game, and it had some color aberrations between the PNG, JPEG, and the HEIF format. So I left that out and just used a natural image instead. But the main reason, the real reason that this is probably going to be a format you're going to see going forward is that Apple have picked up in 2017. So since iOS 11 and the iPhone 7, that's the sort of go-to format. They're not using JPEG anymore for the camera applications on the iPad or iPhone. It's all in HEIF. And one of the main advantages here is that for the much higher resolution images we've got now, we've got built-in hardware acceleration. So the main compression format in HEIF is HEVC or H.265, which you've probably heard of as a standard video codec. And it's also worth noting that the AVIF format and other formats that are proposing new image container formats, they're all using video codecs as well for the still picture coding. So we're all kind of going the way of just stealing elements from video codecs. So one of the main problems here, as you might suspect, and what I would have done if we were doing this in person, was ask how many people had an iPhone. I'll tell you the ratio of iPhones to other mobile devices is about 1 to 4. So about 25% of phones that are out about just now are iPhones. So there's probably quite a lot of people listening just now that have got a HEIF image on their device. But the problem is the support is generally quite poor. So this actually progressed a little bit as I was doing the research for this paper. But fundamentally, the support isn't very good, and especially even in 2018, 2019, so a year or two after the format was launched on Apple devices, it was still very bad. And this led to a lot of articles basically with people panicking saying, how do I do anything with this image that I've taken with my camera? What do I do with it? How do I upload it to Facebook? How do I send it to a friend? And lots of people were basically wanting to say, well, I don't want to use this format. I would rather shoot all my images in JPEG because it's less hassle. Because the standard sort of go-to was you want to export it to JPEG. And this was actually the advice that was given in a lot of forensics resources as well. And I say blog posts here because there really wasn't a lot in the community that was published about this. Some of the main resources I use on the page are blog posts by Cheeky Monkey Forensics, it's called, but I can't remember the name of the actual author. And I think one by CCL Forensics, basically just saying export to JPEG so you can actually open this thing. And I've got a bit of a tool test in the paper. I don't focus on it so much in the presentation, but the paper's on archive if you want to check out a bit more of the detail. So there's very little general understanding of the format, and in fact, it was quite difficult for me to get the resources and get a feel for what was actually going on in the format. And I recently sent it to a friend because I'm looking to take this project forward, and he was struggling himself to find resources on this as well. So there's not a lot out there, which is one of the reasons for this paper, where we want to basically look at it in a bit more detail, figure out what's going on with it, roughly how the compression works, but more importantly, what features it offers, especially features that we're worried about for forensics purposes. I've already mentioned blog posts, and basically we found that the state of affairs isn't great, and it's quite bad news forensically, and hopefully you'll agree with me by the end of the talk. So one of the major things to realize is that this isn't a simple standard image format where you've got one picture inside. So if you think about a JPEG, you've got one image, that's pretty much it. You may or may not have one or more thumbnails, but ultimately they're all representing the same thing. Well, HEIF is a complex container format, so what this actually means is that we can pack a whole gallery of images into the same file if we really wanted to. So on the right-hand side, we can see a screenshot from the macOS preview, which is one of the few tools that actually supports HEIF to a decent degree. And we can see that there's actually 5 images in there. I'll talk about what that grid is on the next slide, I believe. But basically, on most applications, you will only see that grid. You'll only see those 4 images coming together in that grid shape. You won't actually see the constituent components of that file. So we're packing all these different things in, and what we call the cover or the primary image is just the main display image. So it's that grid in this case, or it could be a cropped image or a flipped image or something like that. But we also have multiple master images. So the master images are not the cover image, but they're original images. Whereas derived images are things like grids, overlays, or anything that is used to compose, the derived image is the composed image. So if we're taking multiple sources and meshing them together somehow, that result is a derived image, which is the same as the grid we have here. And we can also have sequences. So we're no longer just talking about still images. You'll be aware that most phones can do some kind of burst shot these days. So you can actually hold down the camera snapshot and get a sequence of images, which can all be contained inside of the HEIF format as well. In a slightly different way, it actually encodes it using the intercoding that HEVC supports. So it's actually more like a video. So you can have a bunch of still images, a bunch of thumbnails, and some videos, and that is obviously a lot more complicated than a standard PNG or JPEG. And we might also have EXIF data. So we've got individual shots can have their own EXIF data about the camera, where they came from, and they might also have multiple resolutions. So they might all have thumbnails, or they might have different sizes of the same image, all in the same container. But as I said before, most applications don't see beyond this standard cover image. That thing that you say is the primary display image, most applications will only see that. So we're losing all of this data in the background. But one option as well is that we can use this functionality to build up bigger pictures. So Apple does this using their camera. They split images up into 512 by 512 pixel blocks, and then they use the grid, which is the exact same as what we had in the bottom right here, and the now minimized grid display, except instead of having 4 images, we have something like 20 or 30, and that with the number of tiles depending on the resolution. So in this case, you can see this Lego man. I've pictured 3 of the tiles upside down because the EXIF data actually tells you to flip the image back around. But that's just 3 of the 512 blocks, and then we can see that if you take enough of these, you piece them back together, you get that full-sized image. And you can actually see that that's marked as primary. The full image, the grid display, is the primary one. And I should note that the main reason for doing this is for performance issues, because separating the image out like this means you can render all the tiles independently and get much better performance and throughput. So if you think about these 100 gigapixel images, you'll be able to process them in a much easier way if you split it across, 8 cores than you would if you were doing it single-threaded, where it may be a bottleneck. So you can have tens of sub-images, you can have different resolutions, EXIF, multiple sequences. It's all over the place, and it really is a container format more than it is an image format, if that makes sense. It's more in line with I think AVI or MPEG containers. Your standard video formats are closer than, say, a JPEG would be. So derived images, I mentioned it really briefly in the previous slide, but basically you create a derived image by combining multiple source images together. So multiple master images, so that could be multiple independent camera images, or in the case of what we have on the right-hand side here for an alpha blend, we've actually got 3 images that are combined together. We've got the image that appears on the left, so you can see that sort of green coming through on the bottom image. And then we've got the image that appears for the rest of it on the right-hand side, that sort of purpley color. And then we actually have an alpha mask. So how do we mesh these images together? Well, we've actually got a bit mask to say, the intensity, the fade, if you like, from the right image to the left image, where that split happens, how much of that color comes through. So then we combine that together and we get a derived image. So you can see there's all these different components that fit together. And you can do other things like the grid, which we saw in the previous slide, or overlays or collage type arrangements. So you're blending master images together with alpha masks with the alpha setup, or you can have a depth mask, which is actually, again, it's a standard component of the camera images that are taken on Apple devices. So instead of having this alpha blend, we've actually got a depth sort of bit mask that, much like my background is, blurs parts of the image and puts other parts in the forefront. And if we look again on the right-hand side, it's not displaying that alpha mask I'm talking about. So this is showing in GIMP 2.10, but we can't actually look at that alpha mask or indeed the depth mask directly. So that's actually an avenue for potentially hiding data. It's potentially an abuse vector because effectively it's just a grayscale image and we can make that whatever we like. And we never actually have to use it. We never have to display it in any way. So we could quite handily hide a bunch of stuff we don't want anyone seeing in auxiliary images, and because there's currently no way to actually view them, that's sort of a black hole for forensics purposes. We don't actually know how to get that out yet, and you can't get it out using current processes. And there's also potential abuse for how the images get put together. So if we think about the Lego grid from the previous image, there's nothing to say that you have to use all of those tiles, and there's nothing to say that they have to be combined in that particular way. So maybe the default composition looks quite benign, but when you combine them all together in different ways, you get different results, which may or may not be of concern. So another feature, this one is actually sort of one of the selling points of HEIF, is that you get lossless editing. So normally on a JPEG or PNG, whatever it is, if you edit the file, or you crop it in this case, so if we take that image on the right-hand side, the full image, and we crop it in a little bit, we're actually just losing all of that data. So that checked data with the lines going through is completely removed on a JPEG or PNG. It's just lost unless it's still present in the thumbnail. So we lose all that data, but in HEIF, it actually keeps that data and it just applies that crop at display time. So what we actually find is all that checked data is still there. We're just kind of changing the aperture or the window into the file a little bit. And you can see how that has potential for abuse, because it might be that something out of frame is actually, part of an illegal image. whereas the thing we're displaying is, it's benign. We don't necessarily care about that. But if we can't pull out all the parts of the image, we might not be able to find that out. And currently, the scenario isn't very good for this. So there's three basic functions that should be supported by the player. We've got rotate, so you just rotate 90 degrees. You can mirror it, so you can flip it. So you want to flip it on its axis, you can do that on the Y or X axis, and you can crop it like we've seen here. And all HEIF players should support these three functions to be properly HEIF compatible. So this isn't so much a problem just now, and the main reason for that is I couldn't find any tools to actually do this properly. I had to use APIs to get this working. But that doesn't mean that it's not going to be a problem in the future, because eventually the support will be not taken care of. It will be supported by Apple. So they're going to leverage this functionality that exists at some point, and this might be an issue, especially when the cover, so that primary display image, isn't necessarily representative of the full image, the full master image that's in the background. So we have to be quite wary of derived images in general. So another thing is that we can hide images, and there's external references. So hidden, I already mentioned that the auxiliary items, your depth map and your alpha mask, they're already hidden, not just by default, but just because you're not supposed to view them. They're not something that the user should be seeing. But you can actually tell the player not to display particular items as well. And it turns out, sorry, I'll just skip ahead a little bit. There's a single bit you can change in the info box for that item that basically just says, don't display this. So there's legitimate reasons here, because if you're building a grid, you might want to hide all the subcomponents of the grid and only show the main one. So think about the tiles in the Apple format, for example. You don't want the tiles showing up independently. You wouldn't want 30 tiles and then a main image. You just want that main image to display. So you can hide all the tiles, hide all the sub-images, and only show that derived image. So that's a legitimate use, but there's obvious scope for abusing this. So have your cover image be a benign thing, hide all the dodgy images in the background. Currently, there's not a good way of seeing that. So all the tools I've found that display these secondary master images, they keep track of this hidden bit and they will hide it by, just because you've told it to. So on the right-hand side here, this is actually a burst shot, but the same thing applies. We've got 4 images at the top in GIMP. We set a single bit, and that hides that third info item. That third burst sequence is hidden completely. We don't see it in any image browser. Another complication is that HEIF can actually point to things external to the file. So we're used to seeing self-contained files where all the content is inside, but HEIF can actually point out and say, here's a URL or here's a URN for additional data. And that's typically going to be EXIF data, but we don't necessarily know the limitations of this yet. And I think this is something that needs to be checked out a bit further. But fundamentally, the tools aren't supporting this stuff. We can't view hidden items at the moment, with the exception of using FFmpeg on the burst sequences. So if there's an animation, you can play it in a video player, you can export it using FFmpeg, and I've got the command in the paper if you want to have a look. And we can get that entire frame sequence without worrying about things that are hidden. But currently there's no good way of doing that with the still images. So hashing is another problem. So normally what we'll do is we'll hash the whole box, so the whole JPEG with all its thumbnails and all the EXIF data inside. We'll get that hash and we'll say, right, use this in a bad list or a good list to say, right, do we care about this or do we want to flag this up for forensic examination? That's a fundamental thing we do in forensics, is have a bad list of files. So this is great in JPEG because we've got a single image. And okay, if you modify the EXIF data, you change the compression features, you change the quality slider, you add a thumbnail, that changes the hash. But it's more complicated in HEIF because you're hashing multiple images. You're hashing, 3 different images as a block. And something as simple as changing the order of these images in the file changes the hash, even though the content hasn't necessarily changed by 1 bit in the actual display and what you see. So we can change the order, we can add in new items. This is all standard stuff that breaks hashes. But another problem is with the image sequences. So those burst shots we're talking about are like videos, they're intercoded. So what we're actually saving on the disk is the delta, so the change between frames. We start with a keyframe and we say what's different to the next frame. So if I had to add in a black frame or a dummy frame, and we're only hashing the full file, then we're changing the compression, even if all the frames are basically still the same except one. So what I'm actually advocating for is we want to be able to basically pull all this out and say, well, I want to hash all the sub images, all the subframes in this. And I realize I'm running on a bit, so I'll just be very brief with this. So the layout, I cover a fair bit in the paper. I just want to give you a quick feel for how this looks. Hopefully you'll sort of understand what the components are now that I've talked about the features. So generally what you have is at the top, you've got header. So it'll say, you know, this is the type of the file. Here's a metadata box. It says picture and the primary image type. So if it's the cover image, what is that and where is it? So where in the file is it located? The second part, we've got a list of all the information items, so individual master images, derived images, that kind of thing, and it tells you about the encoding, so HVC1, but it could also be JPEG in this format, or PNG. So that's the benefit of a container, is it's not limited to particular codecs. And we can specify references to thumbnails and a bunch of other properties, which I won't cover just now. And if we've got an information item, which is a derived image, we can say it's a grid, it's an overlay, it's an alpha, or we could specify EXIF data there. We've also got the properties I mentioned, so we can do things like crop, rotate, mirror, and that's all handled by an image property box as well. And we can see that there's a well-defined order to how these things go, and I've sort of blocked them off, so it's a bit easier to see. And then if we look at a standard Apple image, we can see there's tons. So all of these INFE boxes, all these information boxes, that's all the individual tiles. And then right at the bottom, we'll get that grid to compose them all back together. And then at the bottom of the file, we'll have an MDAT, which you'll be used to if you know if you've looked at lots of video containers, which contains the actual compressed image data and the thumbnail and the EXIF data in the case of Apple. And then right at the bottom, if we've got burst sequences, we've got a move box, which goes all the way back to QuickTime. And we've got tracks and media and metadata, things like timing. So how long should each frame display? So again, that's just to give you a feel. I didn't really want to cover that in too much detail. So I'll just really quickly go through this because I know I'm a couple of minutes over. There's no magic number. So if we're analyzing it using these existing tools, we can't just look for a PNG signature or JPEG signature. We're having to dig into the file a little bit more and say, okay, what is the brand? Does it say HEIF anywhere? And we're looking for a couple of markers rather than just a magic number to say this is a GIF 89A. We're also needing to figure out the box structure. So as I said, it's a very complicated format. So one of the things we need to do early on, like I did in the previous slide, is kind of figure out what's in there and how it's shaped. So how many image items do we have? What order are they in? Do we have thumbnails? Do we have burst sequences? Are any of them hidden? These are all really important things. And we have to do this manually. So what I would say is, actually just use a script. So I've got a GitHub associated with the paper. I'll put the Python script I use for this on, where you're pretty much just doing string analysis to see what the common boxes are. And it's really important that, and I've got a lot more detail about how to do this in the paper, that we identify the bit that hides images and unflip that to 0, so that we display the images rather than have them all be hidden so we can actually see them, because there's no current tools that will let us see the hidden images. And basically it comes down to, at the moment, GIMP on Windows is fine, but you can use it on Mac as well, or the Mac preview tool. These are really the only good ways of seeing still images in the HEIF format. And for videos, my suggestion is to use the FFmpeg tool or some kind of video player. FFmpeg is really good because you can split out every individual frame. And again, I've got the command for that in the paper. Or you can export it to a movie file or an AVI, whatever suits, and then play it to see every single frame. Now, I don't know how well that will work if there's multiple burst sequences that are different, but in this case, there's 4 individual info boxes all with a different mini sequence, and that plays fine. So conclusions and the future of the tools. So hopefully you've got the idea that HEIF is a really complex format. We're long past the days of just looking at a single JPEG and knowing what's inside. The tools aren't great, so we're really limited. And in fact, I tested some forensics tools, and again, they're only displaying that main cover image. And it's open to abuse because we can't process the entire file. So in the future, what we expect of a HEIF compatible tool, and I'm actually looking to address this somewhat in a mini project I've got where I'm kind of trying to use the API to build something where we can view all of these components. So ideally, we want to be able to get an overview of the entire box structure. So what items are there, how are they associated, what thumbnail belongs to which image, what are the EXIF data that is comprised in there, what's set as master, what's set as hidden, all that stuff. We want to also display the auxiliary images. So if we've got a depth mask or alpha mask, or even the individual sequences of a burst shot or EXIF data, how do we view all that? So we need to be able to parse the entire structure and give an analyst a really quick display, because ultimately we don't want them doing this manually. This is going to take a lot of time. And then we want to be able to hash individual items. So we want to be able to say, right, we've got 10 images in here, here's the subhashes of all of these 10 items, and then we can hash the entire container as well, if we felt like it. So it's a bit like hashing the individual items in a zip file rather than hashing the full zip file, which isn't particularly useful. And then have a look at external references. So if you've got URLs or URNs in there, currently we can just do that by looking at the URL, but a future tool should be able to process that and pull in that resource as well. So sorry, it was a bit rushed at the end there, but if you're interested in looking at details for this, you've got the HEIF specification, the ISO BMMF specification, which is actually what HEIF is built on, and that has most of the detail for how the boxes are structured. There's all of the Apple developer videos, which are really good. And there's an implementation by, I'm not sure how to say the name, unfortunately, HEIF, and that's actually the implementation that Nokia Tech are using, which I refer to in the paper. And I'd like to say thanks to James Thompson, who's a friend of mine, who's an indie Mac dev, who helped me out a lot with this. And if you want to contact me, I've got the details up and I'll leave that through the Q&A part. And thanks, sorry I ran a bit over.
Thank you, Sean, that's been great. We have a few questions for you. Petra is saying that that sounds extremely complicated. I think that she refers of having different images embedded in the same file.
Yeah.
And do you think that forensic tools will be able to parse this fully in the future?
Hopefully, by the end of the summer, I'll have something that can do most of it. And I'll have a follow-up paper with that, hopefully. But at the moment, it's not looking great. I haven't even really seen anyone talking about it, which is why I thought it was really important to have this paper to even just make people aware. Because I had a conversation with the police. We had them in to do a guest lecture, and it was actually on Petra's module, because he's a colleague of mine. And I asked them about it, say, well, do you know how this format works? Do you know about it? How do you process it? And this was before I got into the project. And they said, oh, we just exported the JPEG. And I thought, that doesn't sound good based on everything I knew about it. And specifically now that I've written the paper, I'm convinced that we need something and we have to get there soon before it sort of gets out of hand. So hopefully I'll come up with something that isn't necessarily a complete solution, but is an open source project that will get us there eventually.
Good. Tim is asking, does your research address potential deserialization vulnerabilities in interpreters that parse images in the manner that you propose?
No, that's obviously we have to be careful of that because you can put a malicious payload in pretty much anything. I remember a CSI episode where they carved it into a bone, and when they did the bone scanner, it somehow magically hacked the device. But that's where we're at just now. Everything is adversarial in some sense. So no, I haven't looked at it, but that's a good point because the more complicated the formats get, the more targeted the abuse can be. So because we're at the early stage of parsing these formats, you could actually come up with a payload that could even break a standard forensics tool. And that's something to be concerned about until we come up with robust tools for analyzing the format.
Okay. Thank you, Sean. I think that we reached our time limit, but
Yep, sure.
it's been great. Thank you again to both of the panelists.